Hi. Let us solve some very simple problems of binomial expansion. Binomial means there are two terms. If there are three terms, then it is a trinomial. So there are only two terms, and it's a binomial expansion. And they want T7. T7 means the seventh term. So we will not have to write all the terms. It is 1 minus 1 by x whole to the power 10. But there is no need to write all the terms. There is no logic. So what we do is, we just appreciate a pattern that a plus b, just for 10, we try to see the pattern a plus b to the power 10. It is easier to write with plus. We can repeat it with minus. So we will not write all the terms, we will just write a few terms, and we appreciate that whatever is the power that comes first, you know. Yes. And we also know that the last term, and if it is plus, then all terms are plus. That's great. So we know it is b to the power 10. That's easy. Right? I can always flip it as b plus a to the power 10. Then the outcome would be b to the power 10. So naturally that comes at the last because b is later. Simple. And also know that the second term always comes to be 10, and the power of a keeps reducing
9.
1 by 1, and b will come up. So you can also write the penultimate term. You know the last term and the term before the last is known as penultimate. Penultimate term. Last but one, that is known as penultimate term. Is this one? So that would be 10 a b to the power 9. You can guess this. Anyway, so that's 10. But if we write the third term, I am writing the third term here. This is the third term. So you know that it will be 10c2 because this was 10c1. This was 10c1. It will be 10c2. A to the power 8 will be reducing 1 by 1, and b square. Is this acceptable? Now what is TR? TR means the ith term. Let's see. The first term, the second term, the third term. In the third term, you have 10c2. In the 3, you have 2. So in the rth term, what will you get? In 3, you get 2.
R minus 1.
Absolutely. So it will be C, R minus 1. And this is always 10. Because this 10 is 10c 1. That is why 10. So it is always 10. 10c1, 10c2, 10c3. It keeps happening. So it will be 10c r minus 1. And you say in the third term you have 10c2. In the second term you have 10c1. In 2 you have 1. In 3 you have 2. It's a simple pattern recognition. And this sequence is clear. So obviously the rth term is 10c r minus 1. Have you also noticed that whatever is here, the power of b is the same? Just see. 10c2, then b is square. If you write the fourth term, then it will become even more clear. Fourth term of T4. T4 is fourth term. Then you can see it is 10c3. 10c2, then it will be
10c3.
10c3. A to the power
7. B to the power 3.
T3. So just see. Whatever is c3, here it comes.
Yes.
So if it is 10c r minus 1, then it will be b to the power r minus 1. That's for also sure.
Yes.
3, 3, 2, 2. Okay. And this total is always
10.
10. See, it is b to the power 1 and 9. So 9 plus 1, 10. 8 plus 2, 10. 7 plus 3,
10.
10. So that means it will be a to the power
10 plus 1.
10
Minus
minus r minus 1. 10 minus r minus 1 plus r minus 1 would be 10 in that sense. A to the power 10 minus r minus 1. Why? Because 10 minus r minus 1 plus r minus 1. When r minus 1 to z then. So 10 minus z plus z is 10. So if the total has to be 10, there will be 10 minus r minus 1 and will be r minus 1. So that is the TR. Can you simplify TR a little more? We can simplify this TR a little more. How much is this TR then? 10c r minus 1 a to the power 10 minus r plus 1. That is
Yes,
11 minus r. b to the power r minus 1. Yes, no?
Yes.
Everyone agrees? Anyone in this class has a doubt on this? Sure. So, how much is T7 then? Then T7 would be how much? It's very obvious. Now guess.
C to the power 10, 8, 10 C8, 10 C8,
10 C
6,
6.
8.
6 in the 3 it is 3, but in the 4th term it is 3. So in the 7th term it will be 6. A to the power
8,
11 minus r, right? It is the 7th term, so put r is equal to 7. 4. And b to the power 6. And is this sum equal to 10?
Yeah.
Yes. So, do you want a walkthrough again or how do you do it again? This is fine?
Yes.
Okay, we'll repeat. Let us try to do another one. I'll repeat the whole thing here. Find T23 of x square plus b by x to the power 25. Am I going to write all the terms? What would be the total number of terms if I expand?
25.
26. A plus b whole square has got how many terms?
3 times.
3. A plus b whole cube has got how many terms?
5 times.
4. A cube plus 3a square b, 3ab square and b cube. How many? 4 terms. So x square plus b by x to the power 25 will actually expand. How many terms? 26 terms. Okay. So find T23 for x square plus b by x to the power 25. Is this fine?
Yes.
Okay, right. But there is a problem here. In this previous problem, we never considered 1 minus x. We only completed the problem with a. So to come back. Is this clear?
Yes.
We did it only with a, and that discussion we did, but actual a is 1 and b is
1 by x.
minus 1 by x. B is minus 1 by x because we are writing a plus b. But it is 1 minus 1 by x, so naturally b is minus 1 by x. So we didn't complete the problem. We'll come back. We'll complete this and then we'll come back. Okay? Now again tell me. Here it is plus, so it is easy.
Yes.
So we write, we have a plus b to the power 25. Then we'll just write total 5 terms. The first 2, the last 2 and the TR. Is this okay? The first 2 terms, the last 2 terms and the TR. Okay. Now we will guess what is the first term? 25. The next term is?
Last 25 a to the power
25.
a to the power 24 and b.
B.
to the power.
This is acceptable.
Yes.
Okay. Okay. The last term that is also understandable.
Yes.
And what would be the previous term?
25 b to the power 24.
Because it will be b will be increasing 1 by 1. The power of b will be increasing 1 by 1, and a will be reducing 1 by 1. Okay. Now we try to write TR. Again. Now tell me, how much is TR? So we know that in the second term it is 25C1, right?
Yes.
If you are not very comfortable, you can write the third term also. The third term would be how much? 25C2. This was 25C1. So this is 25C2. A to the power 23 and this square. So up to this is also in control. So the third term has got 25C2. So how much is TR then?
25
C
R
minus 1?
Yes.
Sure. And then after that? A
to the power r minus 2.
but it will be easier for you to write the power of B.
r minus 1. And
Exactly. See,
25
the rule,
by
what is happening here, the advantage is that when you're seeing it in the board or in the video or in the class, then you are seeing that how I'm writing it in a sequence. But if it is a book, then the whole answer is there in front of you. You don't know in what sequence they are written. It will be printing the whole thing. Intermediate answers will not be there, right? C r minus 1 and it will be b to the power
R minus 1.
same power, right? But what is the total? 25. So if this power, it should be how much then?
25 minus R minus 1.
25 minus r minus 1. Or that can be simplified. Because 25 minus r minus 1 and plus r minus 1 will vanish. So it will be 25 plus 1 is 26
minus R
b to the power
R minus 1.
r minus 1. Is this point clear?
Yes.
So that's the situation. Now we'll complete the problem. We know the TR. That means the RX term. TR basically means RX term. So what is T23? That's very obvious now. You can look at that and give the answer. You can put R is equal to 23 or you can try to do it again. Fresh. Actually when we do this problem, I mean if I am doing this problem in the exam or somewhere, then I don't write this. This is what I am doing it only to explain you. But that's we directly write it. Now can you try to T23 directly? Tell me. At least you can put R is equal to 23 and complete it.
25 C
25
C 22.
Agree?
A to the
A to the power 4.
No, but I get B to the power
20
power
22 first. It is easier for me to write. So B to the power 22
2
and then
A to the power
3
Sorry.
8
The
cube.
total has to be
25 3
23.
so 3 plus 22 is
25.
25. So easily we can wrap this up. Is this point clear?
Yes.
Okay. Now we discuss this T7 of 1 minus 1 by x once again, but instead of taking a plus b, we take the appropriate example minus b, and we see that how it varies. So plus was easy to understand, but with minus only alternate terms are negative. Alternate terms are negative means the even terms are negative. The first term is positive, and the even term, that is second, fourth, sixth, the even terms are negative. So let us see how it happens then. So T7 of 1 minus 1 by x to the power 10. What is the best way to start? 1 minus b to the power. So we say we have 1 minus b to the power 10. General to the power n not needed. 10 is fine. So what would be the? I'll write first three terms.
A to the power
10.
Then
Minus 28.
extensive one. Extensive one is 10. That's fine. A to the power.
A to the power 9
B to the power 1. So that this one and this one matches. Then plus
10 to the power 6. A to the power 8. B to the power 2.
Perfect. And just keeps happening. Now you know how many will be the total term. How many will be the total? How many total term they will have? You will have how many total term? 11. So the last term will be the 11th term. But you know the even terms are negative. So last term would be positive or negative? Positive. 11 is odd, which means the last term would be positive. This is quite simple. So plus b to the power 10. And the previous term would be negative. And obviously it will be 10. A b to the power 9. So much so is within control actually. Now if you have to find out the general term, then if you actually see, then you are getting whatever is here, it is coming as power of that. Just see, if this is 1, then this minus 1 to the power 1 is minus 1. If this is 2, see 10c2, then minus 1 to the power 2 is plus, so it becomes plus. Are you getting the point?
Yes.
Just see. Okay. So for example, the next term would be how much? The next term will be minus 10c 3 b cubed. Now what is happening? What's precisely happening? Minus 1 cube. And minus 1 cube is Minus. Now can you guess what would be TR?
10.
So it will be 10C.
C.
Then wait. Then we'll fill up. We will fill up, but you have to fill up a sign here as well, and it will be b to the power something rather. It will fill up here. Are you getting my point?
Yes.
Yes. But tell me. So one by one. If it is TR, then what will come here?
R minus one.
Now it's control, because in the second term you got 1. In the third term
2.
you got 2. So at RF term you get
R minus one.
up to this is also in control. Do you see the power of B and this always matches? So B to the power,
R minus one.
and you also know that this will be A, and the total would be
10.
10 minus R minus 1.
so 10
11 minus 1.
minus
R
1
minus
minus 1. So wait, but we have not completed this yet. So 10 C R minus 1 A to the
R
power
minus
10,
R.
11 minus 1.
B to the power R minus 1.
R minus 1. Up to this is also fine. This is okay. Now about this sign. What was the rule for the sign?
Even
What-
one will be
What is the even? But whatever is the number below C here, it is minus 1 to the power that number. Here it is minus means minus 1 to the power 1.
1.
Here it is plus means it is minus 1 to the power 2. What would be here?
R minus 1 to the power
Minus 1 to the power
R. Yes.
minus 1 to the power
R.
R minus 1. This term is how much? How much is this term?
R minus 1.
So it will be minus 1 to the power R minus 1. And that you cannot predict. So it will be continuing to be minus 1 to the power R minus 1, because you don't know R is odd or even. R is odd or even, or R minus 1 is odd or even, you don't know. So you keep writing it as minus 1 to the power R minus 1. So TR is equal to minus 1 R minus 1, 10 C R minus 1, and this term. At this point?
Yes.
So keep sticking to TR. I'll just split this part of the board so that I can use only this part of the board. So now referring to only this TR, so this is TR. I don't need all this. Now it's much cleaner. So how much is T7? Mentally can you do? Now think. One easy way is that if you have already done this, then you put R is equal to 7. So R is equal to 7 is the easy way. But can you try to do it again fresh? Okay, the R is equal to 7, you substitute and write the answer. So you'll have minus 1.
To the power 6.
No, 7 minus 1, right? But as if I'm substituting. So I'm just substituting R is equal to 7. So you just appreciate that. And then 10
C.
10 C.
10 C.
10
7 minus
C.
7 minus 1.
A to the power 11 minus R.
7.
7.
B to the power
B to the power 11 minus
7. But we now think. The even terms are negative. 7 is an odd number. So that means it is positive. So minus 1 to that. What I'm saying, I'm not substituting answer 1. I'm not looking at this. It's not there. I'm doing the problem fresh, straight. So I know that the even terms are negative. Second, fourth, sixth terms are negative. Is 7 is the even term? No. So plus. Okay. Then I write 10. Then I realize that 10C. Now I see second term is 10C 1. 10C. Second term is 10C 1. Third term is 10C 2. So seventh term is
10 C 6.
So can I write B to the, so no, not B anymore. I know the total is positive, so I just write 1 by x to the power 6. Becomes minus, even if I write minus 1 by 6 or minus 1 by x to the power 6 will come to the same thing. Positive is already done, so there will be no negative term in between anymore. Even if I write minus 1 by x to the power 6, it's positive.
Yes.
And I also know that will be 1 to the power something. So what's the point in writing even? Even if I write 1 to the power 10 minus 6, right? So that the total is 10. But what's the point in writing this? Because 1 is an easy number, right?
Yes.
So 1 to the power that is not needed even to be written. So what's the answer? Then it is 10c6 by x to the power 6. So 10c6, whatever is that value. So 10c6 is an integer to the divided by x to the power 6 is the d7. Is this okay? So can we quickly expand these terms? X minus root 3 to the power 4 and x minus, so something is wrong, x plus root 3 to the power 4 and x minus root 3 to the power 4. But we know already for 4 I may not even use NCR because I know that for a plus b whole cube I have 1, 3, 3, 1. You already know this?
Yes.
There is a cube plus 3a square b, 3ab square plus b cube, which means it is 1, 3, 3, 1. You already know it. So for 4, it will become 1, 4, 6, Pascal standard?
4, 1,
1. So 1, 4, 6, 4, 1, we know that we don't have to calculate the NCR and all that. So we easily know that x plus root 3 to the power 4 will be x, I'll just directly write x plus root 3 to the power 4 is equal to
X to the power 4.
x to the power 4, all are plus, so 4 x cube root 3, yes, no?
Yes.
Then 1 4 then
6,
6
x
x
square
square
under 3
root 3
x.
root 3 square, the total is always 4. So this is root 3 to the power 1. This is root 3 to the power 2. Next 4 x
Root 3 to the power 3.
root 3 to the power 3. Okay, then
Plus
the last term,
root 3 to the power
4. Now don't expand this. You will see the alternate terms will cancel out. Now it's easy even to write straight away x minus root 3 to the power 4. What will happen? The even terms will be
minus.
even terms will be minus. So
X to the
power 4 minus
4x cube
4x cube, but I'll write the same thing.
3
Then plus again.
3x square 3
Then
under root 3 to the power minus 4x under root 3 to the cube plus under root 3 to the power 4.
4. But if I add this, so what will happen? Always the even terms are getting cancelled. So what is the answer then? The sum, that is the value of, that is the required sum, is equal to 2 times
X to the power
4. Only I am just writing these terms. And then
6
6
x square
x square and root 3 square is
3.
3. This again cancels. And then it will be root 3 to the power 4.
9.
It's 9.
9 and 18.
9.
18.
Why? 18. Root 3.
9 plus
Root 3 into root 3 is 3. So root 3 to the power 4 is 9. 2 are taken common out already. The total is 18 is what I say. So that will be the answer. Who all has doubt in this? Is it all fine? Can you finish this part and then close this? Can we quickly close this? Now how quickly you can close this? Root 1 minus x square plus 1 to the power 5. So we have to have 5. Now we generally don't remember the expansion for 5. Up to 3 we easily remember. Up to a plus b whole cube is 1, 3, 3, 1. We know that very clearly. Up to 3 it is very commonly known. Then 4 and 5 you have to write twice. That's not advisable. So in this case, if it's to the power 5, then we will write it as a NCR, that is 5C1, 5C2 we will write. So let us write that. I clean the board because these are all solved now. Root 1 minus x square plus 1 to the power 5 would be root 1 minus x square whole to the power 5, and everything is plus, so 5c1 root 1 minus x square whole to the power 4 into 1. Now the logic is that why do I spend so much of time writing this? Because I have minus here, and what will happen here now? All the odd terms will cancel out. Here it is 1 minus x square minus 1. In that expansion the even terms are negative, but minus of that will be positive, which means all the odd terms, the first term, third term, fifth term would be cancelled. So is there any logic in writing the third term anymore?
No.
Is the logic. That's what we have to understand. So what do? We write all the terms and then cancel it just for practice. Next time when you do a problem, then all the terms are not needed if you can make sure of. Okay, we'll just write it for this case. So 5c 2 root 1 minus x square to the power 3, and then 1 is not coming anymore. We're just not writing 1 to the power, 1 to the power. What is the logic? So 5c3 root 1 minus x square, then 5c4 root 1 minus x square, and the last term is 5c5
to the power.
And that's all. 1 minus x square whole to the power 0, because that's the last, and then it will be 1 to the power 5 actually. It is not needed. The last term would be 5c5 is 1. Is this okay for everyone?
Yes.
Yes, please.
Yes.
Now, can we repeat this? Root 1 minus x square minus 1 to the power 5. Though the whole thing is written here, but can we repeat? Only the alternate terms will become negative. Only the alternate terms will become negative. The sign will change. Positive, and then next one will become negative. What will be the first term? Same. Root 1 minus x square whole to the power 5 minus 5c1 1 minus x square to the power 4. This will be same again. 5c2 root 1 minus x square whole cube minus 5c3 root 1 minus x square plus 5c4 root 1 minus x square minus 5c5. Correct?
Yes.
Then what is the required term? 1 minus x square plus 1 whole to the power 5 minus root 1 minus x square minus 1 whole to the power 5 is equal to what? So this minus this vanishes.
Yes.
And this minus this means this becomes plus. So it will become 2 times this term.
5c1.
5c1 is 5. 5c1 is 5. To choose one thing out of 5 things. I can do it in 5 different ways. So 5c1, 1 minus x square root square is 1 minus x, that will be 1 minus x square whole square. Then this will go. Do you understand? This will go. This will go. And this will get added up again. So 5c3 is same as 5c2. Okay. I keep it as 5c3. Solving 5c3 is not the intention. And square of that is 1 minus x square. 5c4 cancels out, and 5c5 minus 5c5, 5c5 is 1. So it will become just 1. I am taking 2 common in any case. So this expansion will be 2 into this. And 5c3 value is what we need to find out. And 5c3 is 5c2, whatever. So 5c3, did I recall? NCR is? Determinant factorial n. Factorial n.
Factorial
Factorial r.
into factorial minus r
Minus r. So 5c3 is how much? 5c3 is factorial 5. Factorial 3, right? 5 minus 3 is 2. And factorial 5 is nothing but 5 into
4 into 3
4 into factorial 3. 5 into 4 into factorial 3. Factorial 3 and factorial 2 is 2. So 10. So this term here is 10. Right? Thank you.